Today, we'll learn how to evaluate the integral of sine of x over the square root of cosine of x using substitution. Our goal is to choose an appropriate substitution that simplifies our integral. The integral we're looking at is the integral of sine of x over the square root of cosine of x dx. The first step is to choose a substitution. We want to choose something that would simplify this expression. In this case, the most problematic part is the denominator, which has a square root. So we let u equal cosine of x. Then we differentiate with respect to x. The derivative of u with respect to x is negative sine of x. Therefore, du equals negative sine of x dx. We notice here, if we multiply by -1, it can give us sine of x dx. Rearranging, we have sine of x dx equals negative du. Let's replace our integral. We place the u in place of cosine of x, and sine of x dx is replaced by negative du. The integral becomes negative integral of 1 over square root of u du. We've simplified the integral to be in terms of u, which is much easier to deal with. But how do we integrate 1 over square root of u? We can use a simple power rule. 1 over square root of u can be rewritten as u raised to the power of -1/2. The integral then becomes the integral of u raised to the -1/2 du. Applying the power rule for integration, we add 1 to the power and divide by the new power. So that gives us u raised to the 1/2 divided by 1/2. Simplifying, this is -2 times u raised to the 1/2. Finally, we substitute back in terms of x since we need our final answer in terms of x. We resubstitute u equals cosine of x back, giving us -2 times the square root of cosine of x. Thus, the integral of sine of x over square root of cosine of x dx is -2 times the square root of cosine of x plus c. And that's how to evaluate this integral using substitution. Thank you for watching.